In this problem, we're going to solve using elimination a cryptarithmetic problem. So a cryptarithmetic problem looks like this. ABCD times 4 equals dcba. Each letter stands for a digit, 0, 1, 2, 3, up to 9. Different letters stand for different digits. And we want to solve which digits go with which letters. So we take a 4-digit number with 4 different digits, multiply it by 4, we get the same 4 digits in reverse order. What could the number be? So notice first of all that 4 times A does not have a carry digit. So looking over at the thousands place, 4 times A gives us D, and there's no carryover into the tens thousands place. So this forces A to be 1 or 2. A were 3, 4 times 3 is 12, and we get a carry. So A has to be 1 or 2. Next, we notice that 4 times D has an A in the ones place, looking over at the ones place of the original number. But any number multiplied by 4 is even. So A has to be 1 or 2, but it also has to be even, so A is 2. And so now our problem looks like this. 4 times D ends in 2, maybe there's a carry into the next place, etc. Now notice that since 4 times D has a 2 in the ones place, then D must be 3 or 8. 4 times 3 is 12, that's got a 2 in the ones place. 4 times 8 is 32, that has a 2 in the ones place, and those are the only ones. But now looking over at the thousands place, 4 times 2 in the thousands place, maybe adding a carry from the hundreds place is D, which means that D would have to be 8. There's no way you could get a 3 there. And not only that, not only must D be 8, but there is no carry from the hundreds place. D is 8, so in the ones place you have 4 times 8 is 32, and then in the thousands place 4 times 2 is 8. So now it looks like this, and we see the 3 carry from the ones place. 4 times 8 is 32, we carried 3. Now looking at the hundreds place, since 4 times B doesn't have a carry into the thousands place, B must be 0 or 1. B can't be 2 because we've already used 2, and anything bigger would give us a carryover into the thousands place. So B must be 0 or 1. Looking at the tens place, we see that 4 times C plus 3, the carry from the ones place, ends in B. 4 times C is even, and when 3 is added, this tells us B must be odd. So we knew that B had to be 0 or 1, and now we know it has to be odd, so B has to equal 1. So now our problem looks like this. And finally, 4 times C, looking at the tens place, 4 times C plus the 3 carry ends in a 1, which means 4 times C ends in 8. But if 4 times C ends in 8, C must be 2 or 7. We've already used 2, so C has to be 7. And we easily check that this works. So, mysterious as it was at the beginning, there's only one possible solution, and we've found it.